The National Electrical Code, specifically Article 300.15, states that raceways, cable trays, or other enclosures used as electrical raceways shall not be used as structural members to support equipment or luminaires unless designed and installed for such use. This means that if a modular wall system or drywall is intended to support electrical components like outlets, it must be specifically designed and installed to handle that load and function safely as a structural element for electrical purposes. Article 300.22 addresses raceways exposed to different temperatures and says they shall not be used unless approved for the condition. If a modular wall or drywall creates an environment where temperature differences could affect the electrical raceway, the raceway must be approved for those specific conditions to ensure safety and prevent potential issues like condensation or overheating. Article 410.16 focuses on the secure fastening of electrical boxes. It specifies that junction boxes, auxiliary boxes, and fittings shall be securely fastened in place and supported in accordance with Section 314.23a. This reinforces the need for any electrical boxes covered by modular walls or drywall to be properly secured and supported independently of the wall system itself, unless the wall system is designed to provide that support. NFPA 101, the Life Safety Code, includes requirements for fire safety. Walls, partitions, and ceiling shall be continuous and shall extend from the floor to the underside of the floor or roof deck above, except as provided for in Section 105.5. Covering duplex outlets with modular walls or drywall raises concerns about maintaining the continuity of fire-rated walls, potentially compromising compartmentation intended to contain fires. When considering the installation of modular walls or drywall over existing duplex outlets, several critical conditions must be met to ensure compliance with electrical and safety codes. Firstly, the wall system must be explicitly designed to support electrical equipment, including outlets. This design consideration involves verifying that the wall system can bear the weight of the outlets and any connected wiring without compromising its structural integrity. It also necessitates ensuring that the materials used in a wall system are compatible with electrical components and do not pose any fire hazards. Secondly, the wall system needs to be designed to maintain proper clearances and provide sufficient access to the electrical components. The electrical codes mandate specific clearances around electrical boxes and wiring to prevent overheating and facilitate maintenance or repairs. The wall system's design must not impede access to these components, allowing for safe and efficient troubleshooting and maintenance activities. Thirdly, the wall system must be installed strictly per the manufacturer's instructions and in accordance with all applicable codes and regulations. Proper installation is crucial to ensure that the wall system functions as intended and does not compromise the safety or functionality of the electrical system. This includes following the manufacturer's guidelines for mounting, wiring, and grounding to prevent electrical hazards and ensure compliance with local building codes. Furthermore, the act of concealing outlets behind modular walls or drywall may potentially violate the requirement for walls and partitions to be continuous, as stipulated by the Life Safety Code. Continuous walls and partitions are essential for maintaining fire-rated barriers within a building, preventing the spread of fire and smoke to other areas. Covering outlets could create discontinuities in these barriers, compromising their effectiveness in containing fires. Whether the use of modular walls or drywall to cover existing duplex outlets is permissible depends on several specific factors, including the local building code requirements, the building's occupancy classification, and the design and specifications of the wall system itself. Building codes vary by jurisdiction and may have specific provisions regarding the alteration of electrical systems and fire-rated assemblies. The building's occupancy classification, such as office, residential, or commercial, can also influence the applicable code requirements. Therefore, it is highly recommended to consult with a licensed electrician and the local building inspector to ensure full compliance with all applicable codes and standards before proceeding with any installation. A licensed electrician can assess the existing electrical system, evaluate the compatibility of the wall system with the electrical components, and ensure that the installation meets all relevant electrical codes and safety standards. The local building inspector can provide guidance on local building code requirements, conduct inspections to verify compliance, and issue permits as necessary. Seeking expert advice can help avoid potential code violations, ensure the safety of building occupants, and prevent costly rework or modifications in the future. Firstly, let's examine the role of the electrical system in a building. It is the backbone for powering equipment, lighting, and various devices, ensuring the smooth operation of the facility. The integrity and safety of this electrical system are of utmost importance, as any compromise can lead to hazards such as electrical shocks, fires, and equipment malfunctions. Secondly, consider the implications of modifying or altering the electrical system without proper authorization or adherence to codes and standards. Such actions can create unsafe conditions for building occupants, increase the risk of electrical incidents, and potentially lead to liability issues for property owners and managers. Proper planning and execution are crucial to ensure that modifications are carried out safely and in compliance with all applicable regulations. Thirdly, emphasize the importance of selecting appropriate materials and components for electrical installations. Electrical components must be listed or certified by recognized testing laboratories to ensure that they meet established safety standards and performance requirements. Materials used in electrical installation should be compatible with the existing system and suitable for the intended application to prevent corrosion, overheating, or other issues that could compromise safety. Fourthly, let's delve into the specific requirements of the National Electrical Code, a widely adopted set of standards for electrical installations in the United States. The NEC provides comprehensive guidelines for the safe and reliable installation of electrical systems, covering topics such as wiring methods, overcurrent protection, grounding, and equipment installation. Adherence to the NEC is essential to ensure that electrical installations are performed in a manner that minimizes the risk of electrical hazards and protects building occupants. Fifthly, highlight the significance of proper grounding and bonding in electrical systems. Grounding and bonding provide a low-impedance path for fault currents to return to the source, helping to protect against electrical shocks and equipment damage. Proper grounding and bonding techniques are essential to ensure the effectiveness of overcurrent protection devices and prevent the buildup of static electricity, which can pose a fire hazard in certain environments. Sixthly, discuss the role of overcurrent protection devices, such as circuit breakers and fuses, in protecting electrical circuits from overloads and short circuits. Overcurrent protection devices are designed to interrupt the flow of electricity when the current exceeds a safe level, preventing damage to equipment and reducing the risk of electrical fires. Proper selection and coordination of overcurrent protection devices are crucial to ensure that they operate effectively and provide adequate protection for the electrical system. Seventhly, let's touch on the importance of conducting regular inspections and maintenance of electrical systems. Regular inspections can help identify potential problems or hazards before they escalate into more serious issues. Maintenance activities, such as tightening connections, replacing worn components, and testing protective devices, can help ensure the continued reliability and safety of the electrical system. Eighthly, elaborate on the potential consequences of non-compliance with electrical codes and standards. Non-compliance can result in fines, penalties, and legal liabilities for property owners, contractors, and other responsible parties. In addition to the financial implications, non-compliance can also compromise the safety of building occupants and increase the risk of electrical incidents, leading to property damage, injuries, or even fatalities. Ninthly, underscore the importance of seeking professional assistance from qualified electricians and electrical engineers. Qualified professionals have the knowledge, skills, and experience necessary to design, install, and maintain electrical systems in accordance with codes and standards. Engaging qualified professionals can help ensure that electrical installations are performed safely, reliably, and in compliance with all applicable regulations. Lastly, reiterate the significance of staying informed about changes and updates to electrical codes and standards. Electrical codes and standards are constantly evolving to reflect advances in technology and address emerging safety concerns. Staying informed about these changes is essential to ensure that electrical installations are performed using the latest best practices and in accordance with the most current regulations. It is crucial to consider the location and environment where the electrical installation is taking place. Factors such as humidity, temperature, and exposure to corrosive substances can influence the selection of materials and installation methods. For example, in damp or wet locations, electrical components must be rated for wet locations to prevent corrosion and electrical hazards. Similarly, in areas with high temperatures, heat-resistant wiring and components may be necessary to prevent overheating and insulation breakdown. Understanding the environmental conditions is essential for ensuring the long-term reliability and safety of the electrical system. Electrical codes often specify requirements for access to electrical equipment for maintenance and repairs. Adequate access space must be provided around electrical panels, junction boxes, and other equipment to allow technicians to safely inspect, troubleshoot, and repair the system. Obstructions such as walls, ceilings, or stored materials can impede access and create safety hazards. Proper planning and layout of electrical equipment are essential for ensuring compliance with access requirements and facilitating maintenance activities. Electrical systems often interact with other building systems such as HVAC, plumbing, and fire alarm systems. Coordination between these systems is crucial to ensure that they operate harmoniously and do not interfere with each other. For example, electrical wiring must be routed away from water pipes to prevent corrosion and electrical hazards. Similarly, electrical equipment must be located away from flammable materials to minimize the risk of fire. Effective coordination between different building systems is essential for ensuring the overall safety and functionality of the building. Electrical codes typically require that electrical work be performed by qualified and licensed individuals. Licensing ensures that electricians have the necessary training, experience, and knowledge to perform electrical installations safely and in compliance with codes and standards. Hiring licensed electricians can help ensure that electrical work is performed correctly and that the electrical system meets all applicable requirements. If electrical work is performed by unqualified individuals, it can create serious safety hazards and lead to code violations. Proper documentation of electrical installations is essential for tracking changes, troubleshooting problems, and ensuring compliance with codes and standards. Electrical drawings, wiring diagrams, and equipment specifications should be maintained and updated as needed. Documentation can also be helpful for future modifications or expansions of the electrical system. Accurate and up-to-date documentation can save time and money by providing a clear record of the electrical system's configuration and components. Electrical codes often require that electrical systems be tested and inspected before being put into service. Testing and inspection can help identify potential problems or hazards that may not be apparent during visual inspection. Tests such as insulation resistance testing, ground impedance testing, and voltage drop testing can help verify the integrity and performance of the electrical system. Inspection can also ensure that the installation complies with all applicable code requirements. Regular testing and inspection can help maintain the safety and reliability of the electrical system over its lifespan. The design and installation of modular walls over existing duplex outlets present several considerations that must be carefully evaluated to ensure compliance with electrical and safety codes. The wall system must be designed to support the weight of the outlets and any associated wiring without compromising the structural integrity of the wall. Proper clearances must be maintained around the outlets to prevent overheating and allow for safe access for maintenance and repairs. The wall system must be installed in accordance with the manufacturer's instructions and all applicable codes. Additionally, the wall system must not obstruct access to the outlets for future use or maintenance. Proper planning and execution are essential to ensure that the installation is safe, code compliant, and functional.